Welcome. Today we discuss few method and some important problems on differential equation. First of all, I discuss what is linear differential equation with constant coefficient. It means some derivatives in the equation, some derivatives will present with third order, second order, first order, but power of degree of each derivative must be 1, number 1, and number 2, all coefficients of derivatives must be constant, not variable like x, y. So a differential equation with constant coefficient is like that: d3y dx2 dx3 minus 4 d2 y dx2 plus 5 dy dx plus 6y is equal to 0. This third order present and linear. Degree of each derivative is 1 and coefficient of each derivative, its coefficient is 1. Coefficient of d2y dx2 is 4 minus 4. dy dx, that of dy dx is 5. So this is an example of linear differential equation with constant coefficient. Now, with the help of some problem, I discuss what is the method of its solution. Let us take the example as d2y dx2 minus 3 dy dx plus 2y is equal to 0. Given that x is equal to 0, y is equal to 3 and dy dx is equal to 4. This is some condition. So if this type of conditions are given, then particular solution can be obtained. Instead of any arbitrary constant C1, C2, etc., a particular value of C1, particular value of C2 can be obtained, and result is with the help of that particular constants. First of all, this is linear differential equation with constant coefficient. Its solution can be obtained by putting that y is equal to e to the power mx be the trial solution. So put this value of y into there. It is d2y dx2 means the dy dx, actually it is equal to m e to the power mx. d2y dx2 will be equal to m square e to the power mx, and y is simply that. Now put all these values here, we get m square into e to the power mx minus 3 dy dx means m e to the power mx plus 2 into e to the power y means e to the power mx. So 0. Two factors are there, 1 and 2. E to the power mx cannot be taken as 0, because if it is that, then all solutions are 0. So only possibility is that m square minus 3m plus 2 is equal to 0. This is known as auxiliary equation, in brief, AE, auxiliary equation. That's one thing, without showing all these things in competitive exam, from the equation, given equation, we can start from here. Auxiliary equation is, what is that? It is second order derivative, so m square. This first order derivative, it is simply m plus 2, it is equal to 0. This is the auxiliary equation. It is directly can be obtained without calculating this and so on. So first of all, you obtain auxiliary equation. Now solve it. If it is second order derivative, it must have two roots. Here roots are m is equal to, by factorizing, m is equal to 2 and 1. The roots are real and distinct. If this is the case, that is roots are real and distinct, in that case solution is y is equal to c1 constant into e to the power mx, m means here 2, plus c2 e to the power x. This is solution of the differential equation if these are not given, and that is answer in that case. So now how to obtain particular solution? We have to put it here, the value of x is equal to 0, y is equal to 3, dy dx is equal to 4. Now putting x is equal to 0 and y is equal to 3, we get 3 is equal to c1 e to the power 0 means 1 plus c2 e to the power 0 means again 1. So c1 c2 is 1. Now we have to use the result of dy dx is equal to 0. For that purpose, differentiate the obtained solution. This is dy dx is equal to 2 its derivative c1 e to the power 2x plus c1 e to the power x. Now put the condition that x is equal to 0, dy dx is equal to 4. So 4 is equal to 2 c1 e to the power 0 means 1 plus c1. Now solving this and that, we can very easily obtain the values of c1 and c2. This is, sorry, some mistake. It is c2, sorry, very sorry. This is c2. Now it is 2. Now subtracting 1 from 2, 1 minus 1, 3 minus 4 is equal to minus c1. This is 0. So we get c1 is equal to 1. Now putting c1 is equal to 1 here, c2 is equal to 2. So we get particular values of c1 and c2. And hence the required solution is y is equal to c1 means 1 into e to the power 2x plus c2 means 2 into e to the power x. And that is final answer. So sum up, actually what to do? Now from the given equation, we start. What is auxiliary equation? Auxiliary equation is this. Second order derivative, that's why m square. First order derivative, that is m minus 3m plus 2. If it is third order derivative, say d3y dx3, here we must get m cube. After obtaining that auxiliary equation, solve it. Very simply we can solve it. So 3 cases may arise. Normally second order derivative differential equation is given. three cases may appear. Number one, the roots of the auxiliary equation is real and unequal, like that case. In that case, we have the equation solution is y is equal to c1 into e to the power first value of m, any value of a, that is c1 e to the power 2x plus c2 into e to the power other values of m, that is e to the power 1 into x. So this is our answer. If initial conditions are given, in that case, from like that, so putting the values of x, given y, dy dx, we obtain particular values of c1 and c2, and putting these values of particular values of c1 and c2 over there, we get the solution. So a second case may arise. In first case, it is roots of the auxiliary equation are real and unequal. In that case, solution will be y is equal to c1 into e to the power m1x plus c2 into e to the power m2x. If roots are real and equal, real and equal, both say m, in that case solution both are m or both are m1. In that case, solution will be y is equal to c1 x plus c2 into e to the power m1x. c1 x plus c2 e to the power m1x, and that is our answer. If initial conditions like that are given, by applying this, you can very easily obtain values of c1 and c2. Third one, if roots are complex conjugate, like alpha plus minus I beta, in that case solution will be y is equal to e to the power alpha x, real part alpha x, into c1 cos beta x, not I beta, plus c2 sin beta x, cos beta x plus sin beta x. So this is our solution. And alpha beta, of course, known from the auxiliary equation. So only unknown here c1 and c2. So answer is in terms of c1 and c2. If initial condition like that is given, applying that, we obtain values of c1 and c2. Yes. Now let us take few more examples of that type. Obtain the solution of d2y dx2 minus 6 dy dx plus 9y. Yes. No initial conditions are given here. So it is second order linear differential equation with constant coefficients. So the auxiliary equation is, we can start from there. The auxiliary equation is, what this? It is m square minus 6 into m plus 9 is equal to 0. Auxiliary equation is this. Solving that, it is m minus 3 whole square is equal to 0. So m is equal to 3 comma 3. Roots are real and equal. So the solution of the equation is y is equal to c1 plus c2x or c1x plus c2. Anything may, you can write anything, c1 plus c2 into e to the power mx, that is 3x. This is solution. If needed, that is if normal initial conditions are there, you can obtain from these conditions values of c1 and particular values of c2. So next, solve d2y dx2 plus dy dx plus y is equal to 0. Solve it. Now it is linear differential equation with constant coefficients. So auxiliary equation is m square plus m plus 1 is equal to 0. And you see its roots are complex. Imagine a complex conjugate because its discriminant b square minus 4ac is negative. And solving, we get m is equal to minus b plus minus root over b square minus 4ac divided by 2a. That is, it is equal to minus 1 plus minus root 3i. It is minus root 3i by 2. That is, it is equal to minus half plus minus root 3 by 2i. It is of the type alpha plus minus beta I. So roots are complex conjugate. Therefore, its solution is y is equal to e to the power alpha x into constant c1 into cos plus c2 sine of root 3 by 2 I. And that is answer. It is, but this type of problems are very methodical, very easily you can do it. Only process you should know, and it requires some practice also. Now let us take next problem. Now I discuss few mixed type problems. Solve 2y minus x dx is equal to x dy by dx. By arrangement of terms, we can solve it. This is actually 2y minus x dx is equal to x dy. Just 1 minute. X dy, it is given, write it, minus x dx also. I have taken it excess, so we have to adjust it. But another x dx, minus x dx to be given in the left hand side. So it is that. So that 2 into y minus x dx is equal to x dy minus y. Oh, minus x dx, that is x into dy minus dx, that is x into d of y minus x. So you see, we get two variables. One is y minus x, only one variable. One is y minus x, this is also y1 minus x. So we get 2 dx by x is equal to d of y minus x by y minus x. Now variables are separated, dx by x, and d of y minus x by d of y minus x, as if it is say t dt by t. So that we get, after integrating, 2 log x is equal to log of mod of y minus x plus c, say log c. C is arbitrary constant. So, and this is the answer. Mind that this problem you can also solve by, from there, it is a homogeneous equation. Why? The dy by dx, is equal to 2y minus x by x. This is first degree, this is first degree, this is first degree. So it is homogeneous equation. Now by putting y is equal to vx, you get same result. Same result, so you have to simplify it. Yes. Now next problem. Now solve log of dy dx 2x plus 3y plus 1. Solve it. So from the given relation, dy dx is equal to, it is log base e. So e to the power 2x plus 3y plus 1. So that it is equal to e to the power 2x into e to the power 3y into e to the power 1. So variable can very easily separated. It is e to the power minus 3y, take it into that side, dy is equal to e into e to the power 2x into dx. E is constant, no problem. So we get dy with e to the power minus 3y and dx with e to the power 2x. Now we can integrate that. And after integrating this, it is equal to e to the power minus 3y by minus 3 is equal to e into e to the power 2x by 2 plus constant c. So after simplifying, e to the power minus 3y is equal to, it is equal to minus 3e into e to the power 2x by 2 plus 3c. C is a constant, 3c is another constant, let it be c1. And that is answer. Now, our next problem. Solve x into y dx plus x dy is equal to plus y into y dx minus x dy is equal to 0. So it is equal to x into y dx plus x dy is equal to, take it into that side, it will be y into x dy minus y dx. Now this will be a perfect differential if I can divide it by x square. So divide it by x square, it will be d of y by x. So if I divide it by x square, we must divide it by x square, so that we get y dx plus x dy by x, they together x, and y also is there, this is also y, is equal to d of y by x. And this one is d of xy by xy is equal to d of y by x. Now, very easily we can integrate that. Suppose this is t, xy is equal to t, so dt by t. So its integration is log of xy is equal to d of, if integration of dx is x, so this is equal to y by x plus some constant, and this is answer. Next problem, y sine of y by x minus x dx is equal to x sine of y by x dy. This is a given equation, differential equation. Now from there, dy by dx is equal to y sine of y by x minus x divided by x sine of y by x is equal to, dividing by x. It is y by x sine of y by x minus 1 x by x, 1 by sine of y by x. Now put y is equal to vx, so that dy dx is equal to v plus x dv dx. Now put it there, v plus x dv dx is equal to y by x. Y by x is nothing but v sine of y by x minus 1. Sine y by x means v by sine v. It is equal to this by that, v minus 1 upon sine v. So v will be cancelled. So we get x dv dx is equal to minus 1 by sine v. Now very easily you can separate variable. It is sine v dv is equal to minus dx by x. Now integrating both sides, we must get minus cos v is equal to minus log x minus c. So cancelling negative sign, cos v means y by x is equal to log of x plus c. This is negative, okay. So this is the answer. Now take our next problem. The differential equation of the curve passing through 0, 1 and whose tangent at any point p x, y makes an angle tan inverse e to the power x into y with x-axis. So problem is, you have to find differential equation. We have to find the equation of a curve. The curve passes through 0, 1 and such that at any point p of the curve, its tangent makes an angle this with x-axis. The tangent at any point makes an angle with x-axis. It means dy dx is equal to tan of that. That is, we must have dy dx is equal to tan of this thing. That is tan inverse e to the power x into y is equal to e to the power x into y. Now it becomes a differential equation and very easily we can separate variable. It is dy by y is equal to e to the power x dx. Integrate log y is equal to e to the power x plus some constant say a. Here also given that the curve passes through 0, 1. When x is equal to 0, y is equal to 1. So log 1, log of 1 is equal to e to the power 0 plus a. It is 0, this is 1, so a is equal to minus 1. So the equation is log y is equal to e to the power x minus 1. That is answer. So, okay. Today, let us stop here. Next day, we also take few more problems. If you feel that it helps you, so please like the video, share it, and subscribe the video. Thank you.